special product multiplying conjugates. Conjugates are two binomials with the same first term A and same second term B, but the binomials have opposite signs. One's a plus, one's a minus. So plus minus or minus then plus. If we FOIL and multiply the first terms A times A, we get A squared. The outer product is minus A times B, and the inner product is plus BA, which is the same as A times B. And the last product is minus B squared. So the outer product and inner product are opposites and add to 0 or cancel out. So the final result is A squared minus B squared, called the difference of two squares. So we only need to multiply or square the first terms and square the second term to get a difference of two squares. So the exercise here is a product of conjugates, and therefore we don't have to do the full FOIL. We only have to square the first term and subtract the square of the second term, which gives x squared minus 121, a binomial difference of two squares. 19, the next special product is the square of a difference, A minus B quantity squared, which is A minus B times A minus B. If we use the FOIL method to multiply, the first terms, A times A is A squared. The outer product is minus 1, AB. The inner product is minus 1BA, but that's the same as minus 1AB. So those last two product terms are like terms and combine to minus 2AB. And the last terms multiply to plus B squared. So the first term and the last term are perfect squares, and we say the middle term contains a factor of minus 2, and this is a perfect square trinomial. Abbreviation PST, perfect square trinomial. A perfect square trinomial will factor as the square of a difference. The example is the square of a difference. Now we can multiply with the traditional FOIL method, or we can apply the formula A squared minus 2AB plus B squared. So A in the formula is 2y, and B is 5. So using the formula, we have 2y quantity squared minus 2 times A, which is 2 times y, times B, which is 5, plus 5 squared. So this equals 4y squared minus 20y plus 25. Number 20, evaluate the expression for x equals negative 2. So first step is to substitute the value of the variable negative 2 for x, and then follow the order of operations, which is in this expression to do the exponent first. So 4 subtract 4, which equals 0. 21, evaluate the expression, which is a second degree trinomial, by substituting negative 3 for x. So we have negative 3 times the square of negative 3 minus 2 times negative 3, subtract 5. Order of operations says do exponents and multiplication before subtraction. So this is negative 3 times 9 minus a negative 6 as a product, which becomes plus 6 minus 5 is negative 27 plus 6 minus 5, which is negative 21 minus 5. Final answer, negative 26. Number 22, square the principal square root of x. And for this radical, which is understood to be a square root, principal square root, by definition, the radicand x has to be positive or 0. The radicand must be non-negative in order to perform the principal square root. So to square means to multiply the radical expression by itself. Square root of x times square root of x, which equals the principal square root of x times x. So now we add the exponents, get the square root of x squared. Now a principal square root with index of 2, we can write this as x squared quantity raised to the 1/2 power. So next, when you raise a power to a power, you multiply the powers, and 2 times 1/2 is the product of reciprocals, which equals 1, so we just get x. Number 23. Principal square root of the square of 2x minus 3. Now, x can be any real number, negative, 0, positive, but squaring 2x minus 3 makes the radicand non-negative, positive or 0. So the principal square root can be rewritten as 2x subtract 3, quantity squared, quantity raised to the 1/2 power. So now when we raise the power 2 to the 1/2, you multiply, and we get 2x minus 3 to the first. But since squaring made the radicand positive or 0, 2x minus 3 must be positive or 0 and cannot be negative. And potentially 2x minus 3 could be negative depending on the value of x. So to guarantee that 2x minus 3 is non-negative, we use absolute value bars around the expression 2x minus 3. Then the principal square root of the square of 2x minus 3, which is positive or 0 or non-negative, will equal the absolute value of 2x minus 3, which will also be non-negative for all values of x. Number 24. A principal square root, by definition, must have a radicand that is positive or 0. And since squaring negative 14 will be a positive result, we can rewrite this as the principal square root of positive 14 squared. So now the radicand is definitely positive, and we can compute the principal square root. We can change this to 14 squared raised to the 1/2 power and multiply the powers, and we get 1. Final answer is 14. 25. The principal square root of the sum. The order of operations says do the operation inside of the grouping symbol, which is a principal square root. So we have the principal square root of 25. 25 is a perfect square, and the principal square root is 5. 26 is similar. We have to perform the operation inside the radical first. So we have the principal square root of 400. And since 20 times 20, or 20 squared, is 400, the principal square root of 400 is 20. 27a is a rule of radicals. It's the nth root of a product is equal to the nth root of x times the nth root of y. We have to pay attention to the index, or the root. If the root is even, like 2 for a square root, then the radicand must be non-negative. But if the index is odd, like 3, then the radicand can be any real number, negative or positive, or 0. 27b. The principal square root of 54, we want to simplify by finding a whole number that is a perfect square, like 9, and 9 times 6 is 54. So this can be rewritten so that the radicand is a product of a perfect square times a non-perfect square, and then separate the square root of 9 times the square root of 6, which equals the whole number 3 times the principal square root of 6. Number 28. This fraction can be separated into a sum of two fractions, 4 divided by 2 plus square root of 4 divided by 2, which equals 2 plus 2 divided by 2, and the final answer is 3. 29a is a rule of radicals. The nth root of a quotient is the quotient of the nth roots. And again, we have to pay attention to whether the root is even or odd, which will determine whether or not the radicand can be negative or cannot be negative. And we have to watch for division by 0, so y cannot equal 0. 29b can be simplified in two ways. Either the principal square root of a quotient is the quotient of the two square roots, which would equal 5 divided by 10, which equals 1/2. Or, to begin with, the radicand can be simplified since 25 divides 100 4 times. We have the principal square root of 1/4, which is the square root of 1 divided by the square root of 4, which equals the same answer as before, 1 divided by 2.